Assalamu alaikum warahmatullahi wabarakatuh. We are just going to start with the second chapter. This on matrices, and we'll discuss the fundamentals of the matrices, different operations on matrices. And this was chapter 2, so our lecture will be 2.1. So we always writing our lecture with the chapter number and the section number of that one. We have already given the definition in chapter 1 of the matrix. I'm just going to repeat that one. A matrix is a rectangular array of objects, or we say elements, written in the form of rows and columns. These objects can be numbers or the function, and they can be of any size. You can have any size. For example, I can write here matrix A. In matrix A, I have this number 2, 1, minus 1, 1, 3, and 5. So you can see here, I can say my size of matrix is number of rows and number of columns. There are 2 rows and there are 3 columns. We're having here in this matrix A, there are 2 rows and 3 columns. So we call this matrix, the size of matrix is 2 by 3. Is 2 by 3. We call it like this one. So similarly, we can have a matrix which can have any number of rows and can have any number of columns. So here we can have a matrix. Another definition I take. We take the matrix B. In matrix B, I'm having here X, Y, Z, and W. So these are the functions. We're having here these X, Y, and Z. So this is also a matrix. This is 2 by 2. So this can be a number or the variables. We can put it in, and we say that these are the matrices. They can have anything we can have in the matrix. A size is number of rows in the number of columns. So here we are having the columns. We are having the rows. And here, these are our columns. So this important thing is the size of matrix. That's the easier size of matrix. Size, this one we can write here more easily. We can say this is our size of matrix. Size of a matrix. Then according to the rows and columns, we can just identify this matrix. For example, here rows are not equal to columns. We say it's a rectangular matrix. Here rows are equal to columns. We say this is our matrix. We call this one as a square matrix. So this is a further classification we can do according to the size of the matrix, that it can be a rectangular matrix and it can be a square matrix. There are many other classifications which can be done, and we have discussed this one the last in chapter 1, in section 1 also. We'll continue that one, and we'll also, because we're going to discuss the algebra of the matrix in this one also. So the first one was the size of the matrix. So here I just want to at this stage introduce one notation. So we can write here a matrix in the following form. For example, I can write here matrix A. I say so my matrix A is A11, A12, A13, A21. In general form, we can write like this: A22, A23, and so on. I can rewrite this matrix only writing Aij. We can see here I is my first value that give me the rows. So we say I in this case is 1 and 2, and j in this case is the second. This j is equal to 3 columns, 1, 2, and 3. So this will be matrix A. I can say this is my matrix A. I write this just as Ij, and I say here I is from 1 to 2, and j is from 1, 2, and 3. So I can just rewrite this one and write a very general definition. I say my A is equal to Aij, where my I is equal to 1, 2, and we're having here M, and where j is equal to 1, 2, and n. So it's having m rows and having n columns, and I can just give you the complete set of this matrix defined by this one, and that's and you'll get the idea how we can write this matrix. And we can write any matrix in that form. We write a general form of matrix in terms of Aij. So here I can write here matrix A, and I wrote the first row. My first row is A. This row is being indicated by this value 1, A is equal to 1. Now then come the column. The first column is 1. This row, this remain 1. A1, A1. The second column is third column. I put here 3 dots. It is A1N. Because our J is changing. J is 1, J is 2, J is 3, J is N. Now we can have the second row start from 2. A to 1. Second row, second column. Second row, third column. Second row, nth column. A31. Third row, first column. Third row, second column. Third row, third column. Third row, nth column. And so on. We just take this one. We write the mth row. Mth row, first column. Mth row, second column. Mth row, third column. And AMN. So we can write in general form of a matrix like this one. This having m rows. This m by n. So as I mentioned that if our rows are equal to columns, then you say here I am having here I equal to j. When I am having here matrix B is equal to Aij, where I is from 1 to n and j is from 1 to n, we call it a square matrix. Why? Because the rows are equal to the columns. And here in this case, we say m is not equal to n, then we call this as rectangular matrix. We're having here this one as rectangular matrix. So this is our general definition of a matrix. We must know that one, that how we can write in terms of Aij. You say Aij, as I mentioned here, I is equal to 1 and 2, I is 2, and j is 3. So we're having here Aij is this matrix defined, and here we're having Aij where I is m and j is n, and then we get here this matrix. So as we discussed in the first chapter also, the square matrix and rectangular matrix are identity matrix. We have already discussed the null matrix. We have discussed this one. We go direct to the properties of the matrix. The first property is transpose of a matrix. Transpose of a matrix is obtained by interchanging rows and columns, other corresponding columns. So we're having this matrix. This is matrix having 2 rows and 3 columns. This is our rectangular matrix. We want to write A transpose. So we can write A transpose. We sometimes write capital T or small t. This depends upon the book, the notation the book is taking. Now here we take the first row as the first column. So we change this row into column, and the second row in the second column, 4, 5, and 6. Now this matrix become here 3 rows and 2 columns. So this AT is known as transpose of matrix A. So we are having the properties of the transpose of matrix. Properties of transpose of matrix. So we are having number 1, having A transpose, we take its transpose again, this become a matrix A. So A transpose of transpose, this matrix A. Then we are having here the second property, we are having A matrix multiplied by matrix B. We take transpose, we open this will be B transpose into A transpose. The order is changing. Then number 3, we are having K is a scalar, A is a matrix, this is a transpose. So this is equal to K A transpose, where our K is a scalar, is not matrix. K is scalar. So number 4, we have 2 matrices A and B. We add them, we take the transpose, this same as, we take the transpose of each matrix and add them. So these are the 4 properties of the matrix. We can just see here the first one. We can just take an example for this one. We already done this one. This is our A is equal to 1, 2, 3, and then we're having 4, 6 and 5. So I take the transpose. Now I will take the columns and changing into rows. First column become first row, second column becomes second row, third column become third row. Is same. As we have done here, we change rows into columns, and here we are changing column into rows. The result is same. The result is same. Then we take transpose of this one again. We A transpose. Again take the transpose. So get here. The first column becomes first row. This 1, 2, and 3. Second column becomes second row. We get here 4, 6, and 5. So you can see it here. You get the matrix A. Because their multiplication is involved, so inshallah, and their matrix multiplication scalar is involved. We study it and then we are going to discuss in that one.